Okay, so in class last time you looked at the simulation of a voltaic cell. That is a cell that spontaneously produces an electric current. The voltaic cell is based on a redox reaction where you have something being oxidized and something being reduced. So when we talk about voltaic or galvanic cells, we're talking about cells that are thermodynamically favored. Cells with reactions that are thermodynamically favored. So when I put everything together and I hook it up correctly, I will get a reaction to take place. And they are all, again, redox reactions. So the reason why I can use this galvanic cell, voltaic cell, to produce an electrical current is because I'm taking the redox reaction, and instead of having the whole redox reaction occur in one place, I'm splitting it into two half cells. And each half cell contains one of the half reactions for my redox reaction. So there are two of them total. So one half cell is for oxidation. One half cell is for reduction. Now, if you remember from the video, you also needed something called a salt bridge. The purpose of the salt bridge is to keep everything neutral, because if I'm running an oxidation reaction in one half cell, I'm going to be producing electrons and positive ions. If I'm running a reduction half reaction in another cell, I'm going to be using up electrons. And I ended up using up positive charges in the simulation. So in order to keep everything electrically neutral, I need the salt bridge. And if I do not have the salt bridge, no reaction will take place. Okay. Then we also had the anode and the cathode. Those are the two areas where oxidation and reduction, those two half reactions, take place. The anode is where oxidation occurs. Always. Oxidation occurs at the anode, reduction occurs at the cathode. Oxidation, anode, reduction, cathode. So to remember that, anode and oxidation both begin with vowels. Cathode and reduction both begin with consonants. So anode, oxidation, cathode, reduction. And there are a couple of mnemonics in your notes about how to remember that also. Okay. So once I set this whole thing up and I get a flow of electrons, I have an electrical current, and that current is called the cell potential, or E cell. Okay, E cell is technically the driving force that moves electrons and ions. It's measured in volts, which is V, so the voltage on a battery comes from the electrical potential, and really a voltaic or a galvanic cell is a battery because it produces an electrical current. So when you put your battery into whatever you're trying to operate, the circuit is completed, and then that battery produces electricity. And that's how that works. So electrochemistry is the basis of batteries, and voltaic or galvanic cells are actually batteries themselves. So when we look at a voltaic cell, and you looked at the zinc and copper one in the simulation, you notice that zinc is being oxidized, copper is being reduced. So the zinc is the anode, because that's where oxidation is occurring. The copper is the cathode, because that's where reduction is occurring. So then we have our salt bridge. In the simulation, it was sodium nitrate. In this picture, it's sodium sulfate. But basically, you want something in the salt bridge, an ionic compound. So when it dissolves, soluble ionic compound, typically sodium salts. But the key thing about the salt that goes in the salt bridge is that it shouldn't react with either of the things that are occurring in the half reaction. So sodium doesn't react with copper or sulfate. Zinc doesn't react with sodium or sulfate, so sodium sulfate's a good choice. And so you notice in the salt bridge, the sodium ions are going to flow into the cathode, the copper half cell, because copper ions are becoming copper metal. So they're attaching. The sulfate ion, so the positive charge is reducing. Over here, I'm producing ions, so the sulfate ions are flowing in here. So you notice you have a flow of negative charge, and then you'll notice that the electron flow is going from the anode to the cathode, and that is always true. Electrons in a voltaic or galvanic cell always flow from the anode to the cathode. So the way you remember that is that the electrons flow in alphabetical order. They flow from the anode to the cathode. So if you were given a diagram of a cell, you should be able to label the anode, the cathode, what's being oxidized, or where oxidation is occurring, and where reduction is occurring. So the zinc is being oxidized at the anode. The copper 2 ions are being reduced at the cathode, and you notice I'm referring to these in terms of the reactants. And you should be able to tell me which direction the electrons are flowing in.